Cal, what is it, October 17th? Okay. All right, let's keep going on these notes. All right, thanks again, Jim. This is very helpful. All right, so general equation for direct variation, okay? So if a variable A, varies directly, is directly proportional to a variable x, we're going to write A equals kx, okay, where k is a constant. Okay. Okay. Or you can write y equals kx, okay? So if y is directly proportional to x, or directly the direct variation, okay, that means y equals x times a number. Okay? If it's inverse, if y is inversely proportional to a variable x, it's going to mean y equals x over k. Or it might be k over x. Sorry, I might have written that wrong. I think it's k over x. It's going to be k over x. Sorry about that. So k is a constant. Okay? All right, power function, okay? If y is a power function of x, we were going to write y equals k x to the a, where k and a are constants. Just some arbitrary constant. Okay. Which of our BFFs are power functions? Yeah, so y equals x squared is one. Y equals x cubed is one. What else? There's some others, right? A is any number. A and k are any real number, real number. So if you guys remember y equals the square root of x, that's equal to x to the 1/2. So that's a power function, okay? Or y equals 1 over x, that's technically x to the -1, right? So that's a power function. And then y equals x is technically x to the 1, right? So that's also a power function. Okay. How are you feeling about that? We got more textbook problems here. Looks like Miss White skipped 37 through 42, and she did 17 through 22 instead. So let's do what she did. All right, so let's get out our textbook problems. Turn to page 197. We're going to do 17 through 22. 17 through 22. So let me circle those for myself. 17 through 22. We're going to do 17, 18, 19, 20, 21, 22. So number 17, if we look at it here, Unit 2 textbook problems. Into these right here, okay? So are we all looking at that? Does anyone need textbook problems? Okay. So number 17, the area of an equilateral triangle varies directly as the square of the length s of its sides. Okay, I write that? Area varies directly to the square of its side. How do I write that? Anyone have any idea? Okay, what's direct variation? What did we say direct variation was? What's the equation for that? Y equals kx, right? So, and then, okay, so area, now we have area is going to vary directly by the what of the sides? Square of the sides. Yep, so that's my answer. The area of the triangle is directly proportional to the square of its sides. And what do they say? Yeah. Okay. All right. Number 18. Number 18. Anyone have any idea for number 18? The volume of a circular cylinder with a fixed height is proportional to the square of its radius. Is this direct variation? So what's the formula for the volume of a cylinder? It's going to be pi r squared h. Okay, I'm going to write this as a capital H to say it's a fixed height, it doesn't vary. Okay, this is the same as pi h times r squared. So V equals pi h times r squared. Is this an example? Is that direct variation? Are you done? Or do you need help her? Okay, sweet. Awesome. First one, you and 2 notes. All right, so is this an example of direct variation or not? You should be able to get this. Do you have any idea? Did they start cold calling people? It is a power function. Okay, so, right, direct variation means that, or V is going to be of the form KR. Okay, so what's my K here? It's pi times H. So this, yes, this is direct variation of the square of a variable, so it is a power function, okay? Or it's of the form, right? We have V of the form K R to the A, right? K equals pi times H, A equals 2. Does that make any sense? Are we confused? Are we lost? It doesn't look like we're lost. I don't see like many perplexed faces. We're just a little tired this morning. All right. You guys okay if I move on to 19? Nineteen. Charles' law states that the volume of an enclosed ideal gas at a constant pressure varies directly as the absolute temperature T. I'm like chemistry kids. What's that again? Was that PV equals nRT or whatever? Yeah. Okay. That's the ideal gas law. Okay. It says with the volume, so if we solve this for volume, the volume V equals nRT all over P, okay? It varies directly as the absolute temperature T, so I'm going to rewrite V equals NR over P times T. So let's look back, right? What's the general form of a power function? It's Y equals K, X to the A. What's my K here? What's my A here? What's my K? What's my A? All right, Alberto, do you have a lanyard? Sure. Thanks. All right, I just have to start cold calling. Let's do, what am I feeling? Caleb, what's that? What's my K, what's my A? Yeah. So what's the factor that's multiplying our variable? What's our variable here? Our variable is T, right? So what's the factor that's multiplying it? So what's my k? There you go, nice. Hey, round of applause for Caleb. Thank you. Tough crowd this morning. Maddie, put your leg on, please. Yep. What's my a? What's my a? What's my a, Silas? So the a is just going to be the exponent on your variables. Yeah, so this is a t to the 1, so the a is just going to be the exponent on my variable. Okay? So this is number 19. Okay, how do we feel about this? Oh, that was 20, sorry. Thank you. That was 20, okay. Are you guys okay if I move on to 21? To 21? Okay. Let's do that. So 21 over here. Let's all erase all this. Okay. 21, the energy, oh, I love this one. The energy produced in a nuclear reaction is proportional to the mass m with the constant variation being c squared, the square of the speed of light. Okay. Okay. So if I have, so if I have, if this is 21, so if this is saying E equals mc squared is what this is saying. Okay. And it's saying my variable is m. So let's write this as E equals c squared times m. Okay. So this is, right, the general formula for a power function is y equals k x to the a, okay? So, Ava, what's my k here? What's my k? My variable is m, so what am I multiplying m by? C squared, right? So my k is c squared. I think it sounds like we're having a lot of trouble with this, guys. You guys really need to speak up when you're having trouble, okay? Okay, I don't know that you're struggling with something if everyone's just going to stare at me. Okay, so let me think of a good way to explain this, okay? So when a variable y varies directly, is directly proportional to another variable, it's written in the form kx. So when we're doing these problems, okay, I think the best way to do it is to write your equation that they give you, write it as your constant, so c squared is your constant times the letter that varies. So m is my variable here. How do I know it's my variable? They say it's proportional to the mass m with the constant of variation being c squared. So they tell us that c squared is our constant, right? And our mass is my variable then. Okay. All right, so this equation is of the form y equals kx because I have a variable e that's equal to a constant times another variable. Just like here, I have a variable y equals a constant times another variable. Okay, so that's why this equation here is an example of direct variation. Okay, E is directly dependent, it's directly proportional to M. Okay, so when I'm identifying my K in these, I'm writing all my constants times my variable, and then my K is just all these constants out in front. Are we okay with that? Okay, and then my A is just going to be the exponent on my variable. So here it's 1. Does that make a little more sense? All right, maybe if we look at more of these, if we look at 22. Okay, if we look at 22. All right, 22. The speed p of a free-falling object that's been dropped from rest varies as the square root of the distance traveled d with a constant of variation k equals the square root of 2g. Okay, so that's saying p equals the square root of 2g times d. That's what that's saying. Okay, it varies constantly. Okay, So, right, this is y equals ax to the a, okay? So what do we say? Okay, here's my dependent variable, here's my independent variable, okay? I wrote this as my constants times my variable, okay? So my k is all the constants that are in front of my variable that I multiply it by, okay? So here my k is equal to what? Square root of 2g, yeah. What's my a? 1, yeah, good job. Yeah, who said a is the exponent on my variable here, which is 1, okay? We should see more of those, okay? And then Miss White had 37 to 42 crossed off, so I'll hold up on that. Yeah. All right, so let's go to the next page of the notes. Text 196. So we're going to go to 196 and do 1 through 10. So what are they asking? They want us to look at each function and see whether it's a power function, given that c, g, k, and pi represent constants. For those that are power functions, state the power and constant of variation. So let's look at number 1. Let's look at number 1 first, okay? Number 1. Okay. So is number 1 a power function? Does anyone have any idea? So is this a power function? Why? I think we're on the right track, right? It's right. So power functions of the form y equals kx to the a, okay? So it has a constant. What is my k? If we can identify both my k and my a, then it's a power function. So what's my k here and what's my a here?
K is negative.
Good job. And what's my a?
5.
Good job. Yep, perfect. Okay. Number 2, JJ. Number 2, what's my k? First of all, is it a power function? And if it is, what's my k and what's my a?
Number 2.
Yeah, number 2.
Is it 9
For k, yeah, good job. What's my a?
5/3.
Sweet, nailed it. Awesome. This one is number 3. Is that a power function? Kind of looks like it, right? It kind of looks like it, but, right, a power function, so this is number 3. A power function is written in the form y equals k x to the a, right? And the number with the exponent, like the base of this exponent here is a variable, right? This has to be a variable. Number 3, why would this not be a power function? What's not going on here? That exponent, right? It's 2 to the x is the base. So the base of an exponent is the number that gets raised. Is that a variable or no? That's not a variable, okay? That's a constant. So this is not a power function. This is not a power function. Not a power function. Okay, it's an exponential function. So that they threw you a curveball there. Okay? The difference is a power function has this, the base is going to be a variable, the exponent is going to be a constant. Here we don't have that, okay? Here it's backwards. Our base, the base of my exponent here is a constant, and my exponent itself is a variable. Okay? We seeing the distinction, seeing the difference? So direct or power function means variable equals constant times variable to the constant. This is variable equals constant times constant to the variable. So it's not a power function. Okay, number 4. Is this a power function? Yeah, kind of is. Kind of a bit of a curveball here. This is okay. Here's the trick. Here's the trick. 13 is equal to 13x to the 0, right? Because x to the 0 is 1. There you go. Kurt, that's a splitter. I mean, that's got a spin rate. That's like Garrett Cole with like spider tech, you know? All right. So what's k? What's a? 0, yep. 0. There you go, that was a splitter. I believe so, yeah. Put direct or inverse. These are the type of variation. So power functions, x is the numerator, you put direct. If it's the denominator, you put inverse. Okay, number 5. Is this a power function? Let's rewrite it as c squared times m, okay? This is identical to one of the other problems. Yes, it's a power function. My k is c squared. My a is 1. Okay, so this is of the form variable. My variable e equals a constant times my other variable, and my other variable is an m to the 1. Okay. What about d? What about d? Is d a power function? What's my k? 1/2 g. What's my a? 2. Yep, 2. All right, so this one, okay, so on the homework it's going to ask you to put if it is a power function, you have to say what the type of variation. These are all direct variation, okay, because our variable's in the numerator, okay? When the variable's in the denominator, like it is over here, right, then it's going to be inverse variation. Actually, I think I have a better way of explaining that. So this is a power function. What's my k? So d is my variable. D is my variable, so what's my k? K equals k, right? What's my a equal to? Now this is not 2. K over d squared equals k times d to the -2, so a equals -2. Does that make any sense? Does that make any sense? Okay. Now, what I want to say here, guys, I just realized a better way of explaining this. When a is greater than or equal to 0, you're going to have direct variation. Direct variation, okay? When a is less than 0, you're going to have inverse variation. Because a negative exponent means that our variable's in the denominator. Does that make any sense? You feeling okay about that? Okay. Number 10. M times A. Is this is this a power function? Yeah. And what's my K? What's my A?
K is M.
And A is 1, right? So would this be direct variation or inverse variation? Direct. Why is it direct? Yeah, because it's greater than or equal to my exponent is greater than or equal to 0, so it's direct. How are you feeling about that? Okay, can we move on? Okay, we move on. The volume of a gas varies inversely as the pressure. The volume is 9.2 and the pressure is 163. Find the volume when the pressure is 74.1. Okay. So volume of gas varies inversely as the pressure. So what's the general form for an inverse variation? For if V is inversely proportional to pressure, let me make that a little thicker. Then V equals, how's V related to P? Yeah, so this is going to be V equals K over P. Yep. And then basically what we're going to do, so now we want to find the volume when the pressure is 74.1, right? So it's going to be V equals K over 74.1, right? And then to get the V here, we got to find out what K is, okay? To find what K is, I'm going to go to this other piece of information that they give me. What do they say? The volume is 9.2 and the pressure is 163, so 9.2 equals K over 163, which means K, if I solve for K, I know that K equals 9.2 times 163, which is 1,499.6. Okay, so that's my K. Okay, so then I can plug that into here, and I know the volume when the pressure is 74.1 is equal to 1,499.6 over 74.1. Or it's about, oh, I died. It's equal to about, I'm gonna have to use the board for the rest of the lecture. It's equal to about 1,499.6 over 74.1. What is that? It's about 20.2. So the volume is about 20.2. I did that kind of fast, I feel like. How do we feel? Are we confused? Not confused? We're just tired. Alright. Let's do this last one, okay? Then we can stop, okay? So the weight of a football player varies directly as his shoe size. Joe is 182 pounds and wears a size 11.5. John wears a size 13, so how much does he weigh? So what's my formula for direct variation? Y equals kx, right? So we know, right? Let's make weight just equal to W. So we know W, right? It varies directly as a shoe size. W equals, I'm going to use S for shoe size, okay? So we know W equals some constant times S, or his weight equals a constant times his shoe size, okay? So what do I need to do first here? How do I find my K? Yeah, so I can plug in when it says Joe, when it gives me Joe's weight and shoe size, I can plug both those in. So his weight is 182. His shoe size, what did it say, 11? 11 and a half. Okay, solving for K, I get K equals 182 over 11.5. So 15, about 15.83 is going to be my K. And now I have everything I need to answer their question. What do they say? John wears a size 13, so how much does he weigh? So we know we don't know his weight, but we know his weight equals my K, which is 15.83, times his shoe size, which is, what is it, 13? 13. So he weighs 205.7. Okay. You feel okay? Let's do the 2.2 homework for next time, okay? 2.2 homework.
Should be all covered here now.